This is a gate problem from the 2023 electrical engineering paper on operational amplifiers. So the problem is given as follows. Consider the op-amp based circuit shown in the figure. Ignore the conduction drops of diodes D1 and D2. All the components are ideal and the breakdown voltage of the zener is 5 volt. Which of the following statements is true? Statement A. The maximum and minimum values of the output voltage V0 are plus 15 volt and minus 10 volt respectively. Statement B is the maximum and minimum values of the output voltage V0 are plus 5 volt and minus 15 volt respectively. Option C, the maximum and minimum values of the output voltage V0 are plus 10 volt and minus 5 volt respectively. And the last option is the maximum and minimum values of the output voltage V0 are plus 5 volt and minus 10 volt respectively. And this is the corresponding circuit. So questions of this pattern had appeared in previous years of GATE also, sometimes in instrumentation engineering, sometimes in EC papers, and this time they have reflected this question in the electrical engineering paper. So this is a combination of the concept from diodes as well as Zener diodes and operational amplifiers, the operation of an ideal amplifier. So with a question like this, the way to go forward is to look at the statements that are given and to understand that they are only interested in knowing what is the maximum and the minimum value of the output voltage. So if we look at this circuit, this is in an inverting topology. So that means if the input goes positive, the output should go negative, and if the input goes negative, the output should go positive. And then if we are only interested in the maximum and minimum values of the output voltage, then we can understand that the maximum value of output voltage can only occur when the input voltage is at its minimum. And the output can be minimum only when the input voltage is at its maximum value. Now the input given is 10 sine of some value. So the maximum value for the input voltage is plus 10 volt and the minimum value for the input voltage is minus 10 volt. And therefore it follows that for the maximum output voltage, we are looking at an input voltage of minus 10 volt. We should apply an input voltage of minus 10 volt to find out the output voltage when it is at its maximum. And similarly, if we apply the input voltage as plus 10 volt, we should be able to find out what is the minimum value of the output voltage. So moving first with application of plus 10 volt at the input voltage. So that means we are trying to find out what will be the minimum value of the output voltage. We can note that the voltage at the inverting input terminal should be 0 volt because of the virtual ground concept, and therefore the current that flows through this resistance of 1 kilo ohm is 10 minus 0 by 1 kilo ohm, and this is the direction of flow from left to right. Now if we concentrate on this feedback path, this current takes two branches. It is possible to take two branches. One is this one and the other one is through this 1 kilo ohm and D1 diode. Note that with an ideal op amp, no current can enter the input terminal of this op amp. Now, if you concentrate on this first branch, combination of Zener diode and this diode D2, it is evident that that this diode D2, it will block this current flow from left to right because it will go to reverse operation mode, reverse bias condition. And therefore, if it blocks this current with an ideal diode, it will behave as an open circuit. Whereas for this top branch, you have 1 kilo ohm resistor followed by a diode, and this diode should be able to conduct that 1 milliamp, that 10 milliampere current. And looking at the position of this diode, this behaves as a forward bias diode. So with an ideal forward bias diode, it acts as a short circuit, or we can model it as a short circuit. So referring back to this diagram, by considering that diode D2 should behave as an open circuit and diode D1 can act as a short circuit, we come up with this configuration. And with this configuration, you can eliminate this branch containing the Zener diode. And if we look at the rest of the circuit, here is a feedback resistance of 1 kilo ohm, and here is an input resistance of 1 kilo ohm, and this is an inverting amplifier's topology. So V0 becomes equal to negative of 1 kilo ohm divided by 1 kilo ohm multiplied by 10 volts. So V0 becomes equal to negative 10 volt, and this is the minimum value that is achievable for the output voltage. Note that the saturation voltage is minus 15 volt and we are less than that. So minus 10 volt is the minimum value for output voltage. Now if we look at the other case, that means we are applying negative 10 volt at the input and we are expecting that the output will be at its maximum value, positive maximum. So this time the direction of flow of current is from right to left, because this node is at 0 volt, this node is at negative 10 volts, and therefore the current of 10 milliampere flows from right hand side to left hand side. And the only possibility for this current to flow in this direction is if from this node V0 a current flows through these two branches. Now once again, if we look at the behaviors of these diodes, the first diode D2, this is in conduction mode, whereas the second diode, this is in blocking mode. It is in reverse bias mode, and therefore as before you can substitute D1 with its ideal model in the reverse bias case where it behaves as an open circuit. So this is D1, it has been opened, and therefore this top branch is eliminated. You can eliminate it from the circuit, and you can only have this configuration when you are applying negative 10 volt to the input. Now looking at the direction of the current and considering that the diodes are ideal, we can note that D2 can behave as a short circuit, and therefore we can replace D2 with its ideal model, and this Zener diode now conducts current in the reverse operation mode. In reverse bias state, it is mentioned in the question that the Zener breakdown voltage is 5 volt. So the voltage drop across the Zener diode can be represented like so, with the cathode terminal at positive voltage with respect to the anode. And so if we look at this output voltage, this is V0 with respect to ground. So V0 we can also consider it as the voltage drop across this diode, because this node is also at 0 volt due to virtual ground concept. So V0 is equal to the voltage drop across this reverse bias diode, which is equal to plus 5 volt, same as the Zener breakdown voltage. And so the maximum output voltage turns out to be plus 5 volt. So if we look at the options that are given in the question, option D is the correct choice.